C programming language has a set of 32 reserved words or keywords, which we can't use to name our data. That's because some of them tell the compiler attributes of our data or how to do the execution of the program. So we can't use any of them. We start to learn them by heart over the course of these videos. And by now we just know the end and return keywords. And in the next section, we are going to learn how to give our data valid names. Okay, now let's create a datum with a valid name. First, I specify the type of datum that it is. We're going to use int, which is the only type we know this far. Then, bear in mind that you can use special characters for a datum name. The only special character that you can use is the underscore, and let's call it number, and then give it a value of its corresponding type, integer, 3. We're going to use the printf function. In double quotation, we write %d, which is a format specifier that says I am going to write a numeric value, and then comma and the name of this datum. So it has the value of 3. Let's run it, and it says 3 successfully. Now let's try some wrong options. We can use our special characters, nor in the beginning or the end. It will throw error. You can start with a number, the name of your datum. It will throw error again. However, in the end, you can place a number. There is no problem. Okay. C language is also case-sensitive language. So we have this name for this datum, but if we change from lowercase n to uppercase n, there will be an error, as you can see, because these two different names are not the same just because of this lower and uppercase letter. So remember that. Now let's introduce some basic concepts. A datum is also called variable whenever you give it a value that can be changed over the course of the program. And when we do create a datum, it is called variable declaration, particularly when you just provide the type and the name without specifying a value. And when you specify a value for this datum, for this variable, it is called variable definition because you assigned a value to this datum. Now let's do a quick review of the printf function. First of all, you have to include it by this preprocessor directive include stdio.h, which contains this function. This will allow us to use it. So you write printf to parentheses inside double quotation and the plain code, the plain text that you want to display on black screen. So hello friend, and that by semicolon and hit run. Really simple. Hello friend. Other way you can use this printf is by using format specifiers, which are a combination of percentage and some letters of the alphabet, in this case D, which specify which type of datum you are going to print. So you specify the type of datum, and then after the double quotation place a comma and you write the value that you want to print. It must match the same type of datum here in this format specifier. Let's hit run. Here, there you go. And the other one is when you do not specify directly here the value of the datum you want to write there on black screen, but you actually take that value from a existent datum or variable. So let's create a variable of type integer called number and give it a value of 14. And now let's say it's going to write a numeric value, and after the comma you place the name of number, which is a variable that contains a value of that type. So it is done indirectly. It says 14. And however, you can also mix all these ways of printing information. You can say hello friend, comma value is, and then you do the same here. You place in this and the end of the sentence this format specifiers that it's going to be like a placeholder. Here you're going to write what? Well, a numeric value that you get from this a variable, this datum. So let's hit run, and it says hello friend, value is 14. Now we're going to use a different function that is called Scanf, which is a scan formatted. It basically does the operation of taking input from your keyboard. So you write something and you specify which type of data it is that we're expecting, and then it will receive it and store it in a previously created variable. Remember that a variable is a datum that can store changing values. So we're going to store it in a in this particular example, we are going to receive a number and we are going to store it in this variable of integer number. Okay, so let's start by writing the format specifier. So it's going to receive a decimal number. So format specifier is %d in double quotes, and then you place comma and this sign, which is the address sign, an address operator actually, and we are going to tell the name of the datum that is going to store that value. So it's going to be the this variable called number with of type integer number. Okay, so scanf will wait for this input of number and will store it in this variable to not lose it. However, to and I end this by semicolon. However, to be able to see the process, we are going to print this message first with printf, and printf will say type a value. No, type a number. Better yet, and then scanf will collect this number and will place it here, and then we're going to print f. Printf. Okay, we're going to print the message. You entered and a numeric value. Where we are going to get this numeric value, so we place comma and it will be stored in number once we get this from the input. So we're going to write here number. Have a look that scanf takes the format specifier of the datum that it's going to receive, but in this part it does not take just the name of the datum that it's going to store it, but it has also this preceding sign, which is the address sign, because it tells uh, where the address of this datum is going to be used for the incoming datum. Okay, so let's run it. Run. So it says type number 38 and enter. I hit, and it says you entered 38. So Scanf took this type of datum and stored it in this variable. So printf takes this value collected by scanf and will tell you enter and this value that I just entered. Okay, now let's do another example with the scanf function, but this time I'm going to introduce you to this new type, which is char, a character that is a letter or symbol, and let's give it a name. Let's say uh, girl, and by semicolon, and then type a character. Let's say type a character, and then we are going to change this format specifier to C, which means character. It is a written symbol, a single written symbol. And here you enter at the end. Also change the format specifier to C because it is a character, and also the name of the variable that holds that collected character in all places. Okay, we're ready. Let's run it. So don't leave any space because it will take the only space. So write with no spaces. The dollar sign I put and hit enter, and it says you entered dollar sign. Now let's talk about this preprocessor directives. The preprocessor is a different software than the compiler. So the compiler will translate this C code to binary executable object code, whereas the preprocessor does some arrangements before the compilation process from C code to binary is executed. So first are executed this directive of preprocessor, and as you can see they are not ended by semicolon because they aren't interpreted by the compiler but for the preprocessor. So what it will basically do in this include directive is to extract some code that is inside this library, this file, that will make this printf function work. So imagine that it will complete something here, some code here, and it's like it is replacing this text by the complete code that it needs to get this to get working. In this case of these labels, we'll do the same. Um, any instance within the program of val will be replaced by the actual value that is 12. So it mainly does some replacement texts for several of these directives within the program, and then the program is compiled. So for instance, I defined this value of val as being 12. So I'm stating this printf value is a format specifier for a number, and then I give this value. So the value of this number that is going to be printed is the value of val. So when I press run, this program is going to be translated and executed, and the first step is actually replacing all those values. So it's going to be replaced here with 12 before being translated to binary and being executed. So remember, it's preprocessor directives which are executed first, and then the code will be compiled. So let's run it. You see the value of 12 here. Yeah, it is. So don't forget that. In the previous videos, we talked what the format is for a function. This is one is the main function. However, there can be other types of functions in a program, and they also have this same format of the type of datum that they are going to return whenever they finish, and the name, these two parentheses and two curly braces. Uh, in this parentheses, sometimes a function can take any input values that are called technically arguments, and sometimes it does operations depending on these values, or sometimes these values are going to be treated or modified inside. So for the present time, we are not using any arguments, any input data, but we can use the word void to specify that this space is left blank, or either actually leaving it blank. So void actually means that these arguments are empty. We are not receiving import arguments. That's something to have in mind before we continue.